Right, welcome. Thank you all for joining me this afternoon for a bit of a whistle-stop tour in terms of maths mastery at Westcott. I hope you all managed to have the opportunity to come into school and see your children and the teachers teaching maths and what that looks like, because that's the best way to get a flavour of how we teach the maths at Westcott. In terms of what the mastery approach looks like, it's to help secure that deep level of understanding over a long-term period and making sure that their maths knowledge is continuously built upon throughout the years that they're with us, and that will continue then as they go through into their junior and secondary school life as well. The concept is originally from higher performing countries such as Singapore, Hong Kong and Shanghai. And the main focus around it is that everybody gets taught in mixed ability classes and it's taught as a whole class group. The focus is on all of the children working together on the same lesson content at the same time. However, that doesn't mean that that's all at the same level. That's when the skill set of the teachers and how we manage using our scheme, which is White Rose Maths, and how we vary that to meet all those individual needs within that one lesson. It also ensures that the children can master the key concepts that they need to learn before moving on to the next part of the curriculum. What we don't want to do is rush through and teach all of these wonderful concepts, because if they haven't got that firm foundation, particularly with place value and number, then it means that those bricks, as we continue adding them, are going to get wobblier and wobblier as the concepts become more challenging as they progress through the year groups. So it's really important that we get those foundations right from the beginning. The way the mastery programme works is having small concepts that are logical, that are coherent, and they're delivered through a variety of different models and images. And that will be through a sequence of lessons that will focus, as I'm sure you're already aware from what your child has been doing in class, it will focus on a certain theme or topic, such as place value, addition, subtraction, shape. But within that, there's really, really small steps that we will work through. If, for example, we're working on a small step and the children are getting it really quickly and they're showing that they are secure with their understanding, we can move on quicker. But it also works that if those small steps are taking longer for the children to grasp, we will make that session longer and cover it over a longer period of time to really ensure they are embedded before moving on. In the classes, the teachers will use a range of teaching methods to support all children. And then as and when those misconceptions arise, they will talk about them, they'll unpick them. And also the teachers will model some of those misconceptions as well. And that takes the children to that higher level of thinking to be able to notice when an adult's making those mistakes as well. For those children that are finding even that really tricky to stay and keep up with in class, on top of their maths lesson that they have every day, there is additional support that will be given to ensure that they're keeping up with the maths, to making sure that they've got additional opportunities to practice those key fundamental skills that they need to be successful with their maths learning. Also, for those children that are secure, we obviously don't want to keep them, I say, just ticking along. We still want to challenge them and make sure that they're getting the very best education as well. And to do that, we look at problem solving, reasoning, really focusing in on their deep level of understanding. So rather than just giving them more to do, we start unpicking the level of questioning and providing those problems that really makes them think about how and why, and explaining their understanding. And I will come on to that in a little bit more detail as we move through this afternoon. So teaching for mastery, I think, looks a little bit like this in the image that I've got on the screen at the moment. It's broken down into different areas. It means that the lessons are broken down into connected steps that then gradually unfold the concept, helping children to really deepen their level of understanding and apply it in a range of situations and scenarios. The mathematical thinking, that's for the taught ideas to be really deeply understood. They have to be worked on, they have to be discussed, we have to be reasoning with them. It's not just a passive experience. We need to give the children lots and lots of opportunities to make those connections. Fluency is one of the biggest parts, and if your child is really efficient with fluency and that comes really quick and easy to them, so knowing their number facts, knowing their number bonds to 10, for example, knowing their times tables, that puts less cognitive strain on them when they're trying to apply that to their maths problems. So for children that have got really good fluency, it tends to be easier for them to continue to build through and work on the different concepts as they unfold. With the variation, that's given them lots of different opportunities to work on the maths. So we begin at foundation, and that will be looking a lot like stories, songs, lots of manipulatives like the cubes. You'll see the tens frames that the children use, really making sure that they can visually see what the maths is built up of, knowing that if I said number 3, they could go and collect 3 objects, for instance. When that goes into year 1, we're starting to develop that further by progressing them onto different manipulatives and pictorial examples that will give them those opportunities, but also alongside some of the written methods and how that would look. Then moving on to year 2, we still use the manipulatives, but it's a lot less than it would be in early years and year 1. And it's getting the children prepared for moving on from being able to visually see the numbers and moving objects and being able to work their mathematics out that way, to using more formal strategies that will then prepare them for the next stage in their learning moving forwards. And that moves on as well to the representations. Some classes we've got beads that they use, we've got reckon recs, which are a little bit like the old school abacus. We also use visuals on the screen. We also have resources on the tables for the children to independently choose what they need to help support them. So we're always looking for those next step opportunities for them to develop their learning, but also to develop their independence in their maths and them knowing and understanding what strategies they need to use. The main focus is teaching for depth. So as I said before, rather than just progressing through and using it more of a tick box exercise, it's very much thinking about the learning that we've done and going deeper, giving lots of opportunities for questioning to develop the children's reasoning skills on, well, why do you know that? How did you find that answer? Can you convince me? I don't agree. And really getting them to use the knowledge that they know, making those connections to really draw out that higher level of thinking, which then results in the deeper level of understanding. Discussion is a huge part of mathematics. We've moved along a lot from having to have physical evidence in books all the time. Sometimes you'll see evidence in your children's work of it being a photograph. It could be a photocopy of something they've done on a whiteboard. And sometimes there won't be any evidence physically in their book at all, because lots of the conversations are imperative to them developing their understanding. And through being able to talk about maths and being able to explain the maths, then strengthens those connections and shows their next level of understanding. So just an image that I've taken from when I've been on some of my maths courses that I found really useful to really show that it's the understanding of how those connections are made and ensuring that we're explicitly teaching the children those connections and showing them, oh, do you remember when we did this in addition and subtraction? Or do you remember when that came up when we did multiplication? Oh, do you remember when we used the tens frame to find that out? Really making those links explicit so they can see the use of the different strategies and the different manipulatives that they can use to support them in developing their mathematics across school. And as it says, it's not about just knowing an idea or just knowing a fact. It's using that knowledge all together to build those bigger connections. So having a look through the progression. So in maths, when we're thinking about what we're expecting the children to do and moving from just telling us what they did to really getting the higher level of thinking, these are the 5 steps we will work through. So to begin with, we're asking them to tell us what they've done. That's the describing. They usually are really good at telling us exactly what they have done. Then we're asking them then to explain, so offering some reasoning about what they have done. It may not be conducive to the argument. It may start bringing some bits of information together, but not having that full picture yet. We then, once they've got that, we move through to convince me. So when they're confident in the mathematical strategies they're using and having a clear understanding of the maths behind it, they will then be able to use language to show us that. So I reckon that this is this because, or without doubt, I know that 2 and 8 makes 10. And using the knowledge that they're already really confident about, already securing, to convince me that something is true. Then we look at justifying, where they've got to come up with an argument effectively to complete the whole reasoning process that's going through their brain at that time. I am doing this because I know this, therefore I know that. So for instance, with addition and subtraction, when we're looking at the inverse, children can say, I know that missing number is 3 because I know 7 plus 3 equals 10. So they're using their mathematical fluency facts that they've already learnt. They're using the inverse to know that they can use an addition to solve a subtraction or vice versa, but they're able to tell us that and explain it. Then the last step is to prove. And that's where they have got a solid, watertight argument that's based on all of their generalizations that they understand and all of their mathematical knowledge that they already know. So there's no way I could turn around and say, but what if? Or have you thought about that? Because they've got all of their knowledge, they've been able to prove it, they've been able to justify it, they've been able to convince it. So they've slowly over time worked on from moving from the description of what they've done to actually proving what they have done. And when they've got to that stage, that's when we know they really have got that deep level of understanding within that subject. This is just a picture which I can send out as well following this call. It's really good to give you some top tips on what kind of questions you can ask if you're talking about maths at home, doing some practicing some maths bits on the White Rose Maths. Even when you're using the videos, there's lots of opportunities to do some of the activities. Then after they've finished having these conversations, how do you know? I wondered why that happened. Oh, I already know that this makes this. So how did you come to that? And encouraging the children to use those words as well. So in class, some of you might have already seen when you were in, giving the children the opportunities to use sentence stems. We can't expect the children to know what to say and how to say it without us explicitly teaching them that. And that's what we're doing currently. So in class, we will be giving them the sentence stems and they can then input the bits of information they need to explain and reason their ideas. They need us to teach them that explicit vocabulary to make sure that they're then able to go to that next level of reasoning and able then to explain, convince, justify and prove all of that to us. At home, what can you do? I know all the time that's one of those questions that everybody wants to know. What can you do with maths? How can you help? I would say the biggest thing to focus on is the fluency, getting the number bonds secure, making sure they are really quick with their factual knowledge about numbers and the relationships even between doubles and halving. In foundation, they're focusing on subitizing, being able to see there's 5 dots there in any arrangement and being quickly able to recognise that, all the way up to year 2 when they're using some of their addition and subtraction facts to help them when they're learning their multiplication and division. So it's really about bringing all of those connections together. The White Rose 1 minute app is fantastic for that. It's 1 minute. The children absolutely love it because they can just go onto it and you can specifically choose whether it's subitizing, addition, subtraction, multiplication and division, and they're continually developing that as well. And it's just a fun way for the children to start trying to get quicker at using the knowledge and number facts that they already know. Also, maths has been one of those subjects for a long time at home, in particular, where not everybody feels strong about maths and knowing how to teach or how to support that. You don't have to be a mathematician to be good at maths. And it's really important to make children understand at home as well that, yes, it might be difficult, but also that's a good thing that it's difficult because we're learning. If we make mistakes, that's really good as well, because we can see how that mistake has happened and we can talk about it. We can learn from it. And that's the most important things to do. Also, a few websites that I've linked onto here as well. So we have the Enrich Maths website that has lots and lots of examples of problem solving activities, lots of different ways to word questions to try and get children to think a little bit more around a subject rather than it just being, say, a sum 3 + 7 =. It could be Bob went to the shop and he collected 3 apples. Mary then went to the shop and got 7 more. How many did they have altogether? Just to get them, so the mathematics still the same, but it's been put into a problem that they're then having to really think about. And if they understand the maths behind it, they then will be able to do that. And a lot of it is questioning. I think my class got quite grumpy with me one of the days because I just kept throwing more and more questions at them to really get them to think about the maths that was taught. And by the end of the lesson, it's that, oh, I really get that now. So it's really important to it's not focusing on the answer. It's more about how you got to the answer. What did you do to get there? Can you convince me? If there was an alien sat next to you right now, what would you tell them that you did? And it just really gives them that opportunity to go to that next level of thinking. And more often than not, it's just reinforcing, have a go. Yes, it's difficult, and that's okay. Have a go, persevere, we'll keep working, we'll keep learning, and having that growth mindset approach to what they need to do. I just wanted to share with you just some pictures from each year group, just to show you some examples of what maths can look like. Because I know coming in just for one morning just gives you a little snapshot and a little bit of a flavour, but sometimes it's not always clear where the learning is. So for foundation, for example, we've got shapes, we've got the maths games, we've got dominoes. They're looking at subitizing even with dominoes. You're also looking at addition. Outside, you're constructing. That's looking at things that are taller, shorter, how many. We've got the interactive whiteboards that are fantastic. So even in independent learning, children have still got that opportunity to reinforce the learning that has already happened. And more often than not, the resources that we use for the whiteboards online come from the Top Marks, come from Enrich, and those are things that you can access at home too. Even in the water tray and sand, there's always opportunities for maths and number. Looking into year 1, you can see it move slightly onto, there's a lot more work at tables, but having said that, there's not a book there. Not all of their work is based in books. They're still reinforcing the tens frame that you can see on the whiteboard. They're using string to make their different 2D shapes. You've got children that are working sums out on whiteboards. You've got groups of children working together to solve a problem. You've got comparing with the different symbols, but also the different representations as well. So there's lots and lots of different ways we hook the children into their learning and make it as exciting as possible, because we all know if you're excited and you're keen to learn, it's going to stick. And then in year 2, moving on, again, very limited bookwork. It is still using those manipulatives until they are secure, and then they can move on from that to then using models that they've used in year 1, but then are more complex, because we show them a different way of using the same model, say for the part whole model, which you can see in the top picture there. And then I've just put in the bottom just some examples of what some of those models can look like as well. So if they're coming home and they're talking about a tens frame, a part whole model, a bar model, this is what we're talking about. And they'll use the tens frame from early years, it gets introduced, and that will continue through each year group. The part whole model begins slightly in early years, but predominantly in year 1. And then we add in an extra level of that when they're in year 2. And then the bar model is particularly just year 1, end of year 1, and then year 2 that we use that. So it continues to progress and move on.